page and engage with the course material, post whatever you learn, whatever you make as tweets. And do not forget to tag us. That is, uh, okay, sure. So am I audible now? I hope. Okay. So hello everyone, and good afternoon again to welcome to our third industry session of Summer Analytics 2026. This is our premier 6-week certification course, which is designed to take you from data basics to advanced machine learning. Now, before we dive into today's technical material, I want to tell you about a new initiative that is Build in Public. Build in Public is exactly what the name implies. It is uh, publishing whatever you learn, whatever you make online, and this will help you by having to explain your stuff to others, which is very good for your own understanding as well. Then it unlocks massive networking opportunities, and it living resume instead of just a paper resume. It creates a work history of your portfolio. So this will very easily get you recruited as well. Also, there are incentives of rupees 10,000 every week. So this is a very good opportunity. Now, how do we participate in Build in Public? That is, the entire initiative is taking place on X. So you just have to read through our blogs on our AIML web page, and whatever you learn, whatever you make, just post it on X and tag our official handle, that is at the rate CIIG, and use the hashtag SummerAnalytics2026. There will be links in description. So this is how you participate. Now let me quickly tell you about today's session. So today's session is very incredibly exciting for our ML journey, that is supervised learning. So if you have ever wondered how streaming services like YouTube or Netflix decide what shows to recommend you and or what to show you on your feed, or if you have ever wondered how emails classify mails as scam, spam, or etc., then you are seeing supervised learning in action. So today we will try to understand how we use labeled data sets to train algorithms. And we will also explore how models learn from historical data to find hidden patterns, minimize errors, and ultimately make highly accurate predictions on new data. Now, before we bring our expert on stage, I have one last reminder to give you all. That is, our second week hackathon is live. So it is the first hackathon in our course yet. It will be very exciting. It will be very helpful for you. This is your chance to apply whatever we have covered so far. So do not forget to attempt the hackathon that is live, and its deadline is basically 14 June, 11:59 IST. So remember the date and the time zone for our international students so that you don't miss. So now on to the main event. Joining us today is an expert AI solution architect from AI Planet, Mr. Prudhvi. They bring us massive wealth of industry experience in architecting, deploying, and scaling machine learning solutions to solve complex real-world business challenges. So, guys, let's welcome him virtually on stage through the live chat. So the virtual stage is yours.
Yeah. Hey, thank you, Pushkar, and really appreciate the initiative. Welcome all for the folks who are joining from different places through YouTube. I'm really excited for this session, and I hope we can get started. Okay, so yeah, I'm not following the YouTube screen, but if you have any questions or if you want to interrupt Pushkar or Prakar, any one of you, please interrupt me for any question answers if we have. Okay.
Yes, sir, absolutely.
Yeah, sure. So I'm sharing my screen. I hope you can see the screen. Is visible. Okay, just give me a moment. Let me make it full screen and let me make. Okay. Go. Give me a moment. Yeah. Okay. Cool. So I'm sure most of you have heard the words. So this will be mostly an introductory session, introducing the concepts, names, and then going into details. Right. So I'll talk about supervised learning, but before we talk about supervised learning, I'm sure you hear a lot of words thrown at you, a lot of jargon, right? So I thought I will clear the jargon first and then we'll go into details. So that was the goal. Now, I'm sure you hear this word a lot nowadays. AI, artificial intelligence, it's everywhere. Okay. So if you're broadly asked to define AI, what is AI? Right. So you have a lot of definitions, right? Crazy definitions, etc. But broadly, what is AI is AI is an intelligent program which solves some of the narrow tasks based on the data you have trained. So the core part of AI is nothing but, I mean, you can use this definition across all the algorithms. It need not be just your coding agents. It need not be your LLMs. It need not be your recommendation systems. So everywhere, the idea is to solve one task, one problem, predict very easily on something using the past data. So in good olden days, so I'll take one example. I'm sure you might have been seeing, you guys all have bank accounts, uh, cards. If you try to log into any app today, you immediately see the loan offers, right? 10 years ago in India, it was not like this. If you want a loan, you go and sit with a bank manager. Maybe 15 years ago, 10 years ago is short. 15 years ago, at least when I was graduating, you want a loan, there's no online application, just go and sit in the bank. In those days, they used to have these rules. The manager used to have these rules in their head. They'll ask your income, they'll ask your portfolio, whatever you have, then repaying capability, what is your age, and then decide whether to give you a loan or not. If they're giving the loan, then how much? Today, it is not like that. Most of the banks in India today have an online process where whether you will get the loan or not is decided directly online. You feed all the information, the same information the manager used to collect, you feed it. There is an credit risk algorithm which is running underneath, tries to understand whether you will repay or not, and it predicts, okay, you are eligible so for this much income. And meanwhile, by the way, today, in the last 2, 3 years, the applications were so powerful that you can connect uh, accounts from multiple banks and get all your income statements for last 1 year. Then all income will be analyzed in the process itself within 1, 2 minutes, and then your income will be calculated, your spending is calculated, then based on that, your loan is generated. So all this is happening because they have got extensive data. They have trained those data and built a machine learning algorithm there. So that's one example of AI. In fact, if you look at large language models, the chat GPT, you use it day in and day out, is also a model, okay, trained on millions and millions of text data from the internet. Okay. So that brings us to one particular point of data, one particular point data. What are the jobs in data? So I kept in mind one thing, most of your students will be coming into the job market. So I want you to understand the broad data world, though the AI is the shiny part of it. Today, you have three main things in which a lot of jobs in the market will be available based on the data. So when the companies maintain data, they need broadly three main things to do. One is storing and moving the data, in short. So I gave a very simple name. What do you mean by storing and moving is, imagine this company is getting millions, billions of transaction data, etc. So you need to architect those systems, After architecting those systems, you store them in data warehouse. So on the production side, and then once the data is stored on the production side, then it needs analysis, it needs to be built into models. You can't run it on the production databases, you pull it. And so the entire world of data, where the data generation, storage, processing itself is a field on its own. In good olden days, you used to call it as ETL, extract, transform, and load. Now you call it as data engineering, right? For example, JP Morgan has some transaction data they have been accumulating to last 10 years. Now they gave a contract for Accenture to build a, let's say, financial prediction model on top of it. So first thing is they need to share a data, copy the entire base to some other database which Accenture has access to, and these guys start analyzing, building it. So it's a simple task there, right? Moving from one data, just copying your database and creating. And when at scale, these tasks are very, very high actually. So organizations keep on growing, keep on moving from one cloud, one provider to other provider. That's all your store ETL part. And now it's called data engineering. You have job roles called data engineers. Spark, Scala, and Python are one of the core skill set. The next part, this is where a lot of my specialization is with, this is where I work, insight and story building. Good olden days, it's called as business intelligence. Tableau and Power BI being one of the tools wherein you connect your database, build visualization, build dashboards, deploy these dashboards, etc. And the third part is models, wherein in the models case, hey, I want to predict, okay, if my sales for last 1 year are like this, how much sales I will have for next 1 year. So that's what your models are. Good olden days, we used to call them statistical models. Now we call it AI. So this is where you have a data analyst role sitting, and this is where you have a data scientist role sitting, data scientist. And of course, nowadays people call it as AI engineer role also. So these are the broad roles as a fresher you're gonna see in the market. And remember, if you're building, if you're taking a data engineering path, you are going into data engineering side. If you are going up into BI and analysis part, you will be more on this side. The data world broadly bifurcates these two into two parts actually. So when you're making choices on your career, make sure on which side you are. And I'm sure you guys are in analytics club, so you are more interested in this part of it. Cool. Now there is one more interesting thing happening in last 3 years very specifically, okay, which is a broad specifically bifurcation is happening with the types of data. So if you look at what are all the data this organization's companies store, we had structured data. Structured data as in tables with rows and columns, sits on your Excel, sits on your SQL databases, right? Or it could be any structured databases, need not be SQL. So the most common examples could be customer data or transactional data. You have a retail store, retail chain, all the transactions happening every single day, all the inventory available, all the inventory orders in future, all this is transactional data. And in short, we call it as tabular data. Why tabular is it fits in the form of a table. Need not be one table, of course. It could be multiple tables, but you call it as a tabular data, right? And and the next one is unstructured. Unstructured is when data does not have any predefined structure, or it's not easily organized in a tabular format. Best example, text documents, images, audio, visual, videos, etc. And then you have semi-structured also. So by the way, some of the text data can be stored as JSON, XML, also semi-structured. So there is a slight overlap between unstructured and semi-structured, but broadly your images, audio, visuals are called as unstructured data. Why is this broad classification important is your entire field, your entire role will change with what data type you are working with. 10 years back, 5 years, sorry, not 10 years back, 5 years back, all data scientists used to work with all this kind of data, everything. But nowadays, there's a specific bifurcation going on. People who work with structured data are becoming more of ML engineering side. In fact, the field is also ML engineering. And people who work with images, audio, visuals, with large language models, transformer models, vision models, vision transformers, etc. They're increasingly picking up a role called as AI engineer, actually. And so that's where I wanted to give that big picture. So data, when if it is tabular, the most often used field is machine learning. Typically, your big pharma, e-commerce, retail, manufacturing, FMCG, all these industries have a lot of tabular data. They're still doing a lot of machine learning, let me tell you. Though the buzz is around AI, they do still a lot of machine learning actually. And in India, if you look at consulting companies like Fractal Analytics, Mu Sigma, pure play consulting, not your DCS Infosys kind, pure play consulting like Fractal, Mu Sigma, Tiger Analytics, Cartesian Consulting. There are few names. They've done very good job on AI side. If you look at their advanced analytics teams, much of that is machine learning as of today. But it is going to change because these guys are increasingly bifurcating into or moving into AI kind of roles also. So what is AI kind of roles is when you work with text data, okay, NLP, natural language processing, applications like text classification, extracting meaning from the text, clustering the text, building a RAG application, retrieval augmented generation on top of text. That is called as your NLP and generative AI. So I've specified the models which we use also, but this is the majority as of today. 80 to 90% ROI generating use cases are happening in this. This is the brand new thing in the town. So much of the growth will happen in this side. And you guys first learn machine learning very well, especially supervised and unsupervised. Not a very hard topic. I'm telling you, it's much easier than your math 3 and math 4. It's just that you need a lot of practice on Python. Then once you learn this, you learn your AI as also. Don't jump into generative AI, all those things without learning machine learning fundamentals. Now, that's where the modalities of data come in. And if you ask me, hey, Prudhvi, can we put the entire AI in one Venn diagram? That's how it is. Your machine learning is the big chunk. Deep learning is a part of it, and Gen AI is a much smaller part of it. But as we know, there's a lot of use cases coming in. Entire industries are getting transformed with Gen AI. So that's the future. That's where future growth is actually. Now let's talk about problems solved with AI. Or when I say problem solved with AI, I'm very specifically talking about tabular data, because it is still one of the most prominent data which we get. And let me tell you, a lot of ROI is there. You go and look at Musicma or Fractal, their clients like Unilever or Procter and Gamble kind of FMCG companies pay tons of money just to predict future. So which, because that gives them an idea of, hey, how much to sell, how to sell. Very good use cases in retail are still unsolved. So there's a lot happening on that side also, right? Now we'll talk about one particular problem called as regression. So if you have studied M3, M4, if I'm sure you remember this word called regression. What is the meaning of regression? Regression is basically curve fitting. That means if you give me a set of points, I'll find a line or a plane or an equation passing through it. That's that's basically regression in the mathematical terms. Very simple problem in terms of mathematics actually, but all of its meaning or all of its power lies in when you apply it to real world. And in real world we use linear regression very heavily, wherein you have a linear relationship between some variables. Actually, here I've taken an example of GDP per capita and life satisfaction. So my life satisfaction is very difficult to predict in some of the countries. Why? How do you measure life satisfaction? It is very subjective. You go and interview tons and tons of people, send out surveys, ask them answer multiple questions on multiple dimensions of the life, and then you arrive at a final number which is acceptable. And doing this for every country is very hard task. So what these guys said is that, hey, let me relate it to GDP per capita. Okay. And after I relate it to GDP per capita, for the countries where I cannot go and do these surveys, or for the countries where I'm not willing to do it, let me get their GDP per capita. For example, the country has a GDP of 30,000. Okay. So I'm going to draw a line here, and using that line where it exactly meets, for example, that's 6. So 6 is going to be my life satisfaction for that country. So here I am not calculating the life satisfaction. I'm just trying to predict it for the future using the past data. So how did I do it? I get all my points where X and Y is there. In general, typically in supervised learning, the idea here is you have X and you have Y. This is mathematics. In terms of data, you call it as features and you call this as target. So you get some of this past data. The number of rows could be in your hands as much as possible. And these features could be one or many. By the way, I have taken GDP per capita as my feature here, only one feature, because it is easier to understand regression in a single dimension. But in practice, we don't do single dimension, we'll do multiple dimensions. That means multiple features do exist actually. So that's the idea of regression. Any examples of regression from your real life? Anyone? You can type it out in the chat. I'll give you a moment. Maybe possibly I'll shift to the screen also. I'll resume the screen share. Just let me navigate to what you guys are typing out. Pragar, I hope it is okay to let people ask questions and respond.
Yes.
House price prediction. Okay, very good. Anything real life, guys? That means you see in day to day. House price prediction is a textbook example. Of course, some companies do it. Okay, who is predicting marks? Which IIT is predicting marks? Anything real life, which you see on your mobile apps day to day, where regression is happening in action. Okay, very nice. Okay. How do you guys travel to your college from after your hometown visit?
Yes, so some of us travel by train, then some travel by airplanes.
Nice. And on the when you're booking tickets, do you see anything example of regression?
Yes, I'm sure the dynamic prices of
Yeah.
flights.
Very
That is
good.
satisfied regression.
Yeah. So the dynamic pricing in the flights is the best example. And how many times? So is Zomato and Swiggy allowed inside Guwahati campus?
They are now. There is also Blinkit just recently opened.
Oh, they just launched Blinkit. Okay. So on Blinkit, you see ETA, estimated time to arrival, right?
Yes,
If
yes.
you order some items, right? So your ETA prediction, not only on Blinkit, by the way, it is coming from Google Maps, by the way. Okay, you mark a destination and it shows you number of minutes, right? And this number of minutes changes in real time. Let's say 56 minutes it shows. You start, right? And then there's a huge traffic. It goes above. So it's a regression in real life. Okay. So if you try to look at your Swiggy app itself, the price also on Zepto, the price changes. Your price and your friend's price are completely different. Maybe 6 months ago or 1 year ago, there was huge outrage on Zepto. Your account logged on to Android device was showing lesser price. Account logged on to iPhone device was showing more price. That means they were taking the phone model as one of the feature in your price actually. So your price, and let's say if you keep phone model as a feature, right? And because of that, what is happening? In fact, I'm sure they might have put phone price also, market price into their feature engineering, okay, which resulted in better pricing. So that means people who afford iPhone. So the idea behind it is Zepto was thinking, hey, whoever could afford iPhone will afford more prices for tomatoes and onions also. And it rarely happens, right? You compare the prices with your friend who compares tomato prices. So these guys took advantage of it, and they still do. It's a dynamic pricing world, right? So that's some of the examples in real life. They are used in and out everywhere, and that is the reason it has become very popular. Now, more on B2B side, for example, Amazon, if you try to think of it, they have next day delivery in Hyderabad. Okay. So how do you think that they deliver everything next day? So some people say that, okay, Prithvi, they are storing a lot of items in the warehouse. Amazon has 1 million items catalog, right? How many things they can store in a warehouse, right? You can't store. So what they do is they do demand planning. How many iPhones are sold in Hyderabad in next week? Okay. If it is 5, then they are going to ship exactly 5 iPhones on Monday for the next Monday. Okay. This way they optimize the warehouse space. So basically they're doing everything dynamically. So from the producing place. So for example, iPhones are directly imported to Chennai. From Chennai onwards, they keep it to spreading to every place. So they ship only the number of phones which are required or purchased in that city. So they know that you're going to order tomorrow. Not exactly you, but they know that 5 people order in Hyderabad every day, every week for an iPhone. So they ship 5 phones. Remaining, the warehouse will be. So this is why you need a lot of tech people in companies like Amazon, because they're continuously building models, continuously optimizing their logistics, because everything is cost. Maintaining, putting 100 iPhones, shipping 100 iPhones and keeping them for next 6 months is not effective. Ship only 5, sell this 1 month, that's it, right? So Amazon aggressively optimizes it. When I say Amazon, it is applying on Flipkart. It's applying on every company. Every big retailer does it, not just Amazon. Today, every big retailer ships to the places based on the demand forecast, not based on vague idea. Okay, I'll ship 10,000 here, I'll ship 10,000 here. No, they don't do it. They do it based on the demand. So demand forecasting is one very good regression application actually. So that brings me to the idea of features and target. Okay. So what is supervised learning, by the way? Supervised learning is basically a learning paradigm. Okay. What is that learning paradigm here is your target variable. This is called your target, or in mathematical terms, you call it your y variable. Your y variable is deciding the equation, linear regression equation. So you generally try to take this inputs and give it to your equation, right? Which is like m1 x1 plus m2 x2 plus m3 x3 plus m4. How many features I have? 4. Let's say m4 x4 plus m5. This is my price prediction model. Now I give all inputs 12, 25, yes, high, etc. And this model is expected to give me 452 as output. If it doesn't give, what will I do? I'll go and change my M1, M2, M3, M4, M5. These are called your weights, thetas, parameters. There are several names, coefficients. All this mean the same thing. So what a supervised learning is, you keep on changing your weights such that for the particular data, whatever I give the input, I'll get the same output. So that's the whole idea of supervised learning. If I go back and explain in terms of equation, imagine why is this line not selected? Why is this line not selected? Let's say 1, this is 2, this is 3. Any number of lines are possible, right? To those set of points, you don't select it. Why? Is because the line number 2 is the one which is actually passing through all the points, passing close to all the points. So we have this concept called as error or cost function, error or cost function in the supervised learning. So what is that error is, hey, if I'm taking a line, okay, I'm calculating this as my mistake. So let me take the red ink. So this is the point and this is the line. The drawn red line is the error I'm making. Because if I take the same prediction, same point, same x as input, the output is going to be what is on the line, whereas the actual point is here. So the difference is called as my error or residual. So if I have to give it in terms of equation here, for example, the trip price has to be 452, but your model says, hey, it is not 450. Your model predicts it as 420. Okay, predicted price. So that error is going to be 32. Right. So what is supervised here? The supervised is, hey, I'm looking at your actual expected output. I'm looking at your predicted output. I'm comparing both of them with a cost function. And if the goal is to minimize this cost function. How do you minimize it? By changing the weights. So the idea here is keep on changing my weights, keep on moving my weights such that my error is the least. Error is least. So that is the core idea behind supervised learning. That's called as a paradigm, wherein you have some weights, you have parameters, you keep on moving them such that your loss will be the minimum. And this is basically an optimization problem. When you think of machine learning, I'm sure some of you guys have learned optimization, or maybe in future you will learn through optimization course. Machine learning is an application of optimization algorithms. That's it. So what are we trying to do? We're trying to minimize the loss. And by the way, in the regression, your loss is nothing but called as loss. Sum of the squared error, which is nothing but y actual minus y predicted whole square across all the points, sigma I equal to 1 equal to n. So here you take actual prices, you take the model predicted prices, and you square them, you add them. That's called your SSE. Now you keep on changing the m's coefficients such that this loss will come down. So that is the idea behind your supervised learning algorithm. Right? So that's one problem in your supervised learning. One problem is regression. And in practice, this is almost 50 to 60% of your use cases in real life are regression problems itself, one or the other form. And there are several versions of regression also. Maybe you first learn OLS method. The method which I just showed you is called ordinary least squares method, but there are other methods as well. Now let's talk about classification, right? So this is the next most important problem you face a lot in your real life. Okay, so what is classification here is the goal is not to give a number to predict a quantity. The goal is to predict a class, yes class or no class, or yes class, maybe class, or no class, based on certain features. Features are constant always. So here I have taken x1 and x2 as features. Features are always constant. But what we are doing is a classification problem here. So I'll give you some example. Credit default. As I told you, the banks today, when you look for the personal loan, okay, the first thing they look for is risk, whether you will pay back or not. If you're a high risk customer, then they don't even allow you. They'll reject you. If risk is not there, then they will look at the amount, how much amount to give you as a loan. So customer will pay back or not. Credit default is a big classification problem. Second, customer churn. I'm sure you guys have Netflix applications, right? You watch it. Now, let's say for 1 month, you're busy with exams and you don't watch it. You don't even log in. Suddenly Netflix starts getting worried and it starts sending you emails. So when you watch at regular pattern, they don't send you emails. Okay. But when you stop watching, the frequency of emails goes up. Why? Because they're worried that you might cancel the subscription. And many of your SaaS applications, if you see online, you try to go cancel the subscription, subscribe. After trial is over, you try to cancel, then they'll show you a discount offer. If you normally subscribe, they don't show it in the workflow also. But if you try to cancel it, then application goes up. Now, this is happening at scale. There is no person sitting there. Or sometimes it's not hard-tied also, or hard-coded always. Utility companies do this a lot. Your Airtel, Jio, etc. They give custom offers. Even Zepto and Swiggy also. You don't use Swiggy for 2 months. The third month you go, they'll give a discount coupon. Right? So these are all happening at scale. These are basically predicting churn. Is my customer moving out or not? If they know that you are moving out, they implement some sort of promotion there, like Swiggy giving a discount, Zomato sending emails, right? All those things. Any examples, any other examples of classification you see from your real life? Please comment from real life.
I mean, there's one, like I said, classifying emails.
Yeah, by classifying emails. Very good. Spam or ham. So, how many of you know how old is the spam detection problem? from when Google was attempting the spam detection? Gmail.
So it must be pretty old, like 20 years at least, right?
Yeah, correct, correct. So in 2009, I have got my, not 2009, 2007. That's when I got my first Yahoo email. And in those days, they had an email classification, spam. So as soon as the email started, right, the biggest problem is the spam classifier, because people keep on getting emails and then they just shoot any random emails. Even today, it's a big problem. And more sophisticated attacks are happening. Sophisticated ways to send spam are happening. So Google has. So by the way, so no, anyone worried that AI will take away data science jobs or AI will take away AI jobs? Don't worry, because these models are not like build once and use forever. Okay, so when you build models in real life, let me tell you, they need continuous retraining. They need continuous fine tuning. Okay, so they're not like, hey, build once and leave it. So it needs continuous effort. And as you know, that's happening with OpenAI and ChatGPT, GPT-4, GPT 5.5. So models always get outdated. You need to retrain them. And this applies on the classical side also. Your tabular models also get outdated. New data comes in, new feature comes in, you retrain and again do it. Okay, so that's about unsupervised. That's about supervised algorithms. So far, I'll have more things, but I'll talk about one more application which is very prominent. Uh, uh, I need another 15 minutes more. I hope I have it right. So it's what is the scheduled?
Yes, right, sure.
Yeah. Okay. Got it. So clustering is one more application segment. It's also called as segmentation, right? So think of it in real world. Let's say retail customers are there. A retail store is there, right? So this retail store guys have transactional data, and attached to this transaction, let's say, okay, I got mangoes, I got some pickles, I got some veggies, etc. But attached to this, they have an age and gender information also. Very basic. I'm talking about offline retailers, not online retailers. Online retailers know everything, your bank balance, your battery also. Right? So they have that privilege of knowing you. That's why Zepto could do pricing so better. Offline guys don't have, right? So they have to segment their customers first. Who are my customers? What they buy? And how they fall into different groups. How can I target them? This is a very big problem for kind of Walmart or Costco guys who still buy groceries of offline. Americans, they do buy groceries online, not like our Indians who get in groceries online nowadays, right? Similarly, think of banks. Banks have a lot of customers, different profiles. So when banks come up with the savings accounts or with their credit card offerings, they need to find groups of similar people. For example, if you take a bank is interested in selling it to high net worth people who travel a lot, high net worth people who shop a lot. Okay, budget minded people who shop a lot online, right? Go and look at the SBI card website. You look at the type of cards, you'll understand clustering. They've done a really good job. Of course, for example, you can look at HDFC also. So any major credit card provider in the bank has to optimize for the subgroups in the data, and that they do using clustering. Same thing nowadays being applied for movies also. Look at movies closely. Okay, you will have some scenes very particularly for a set of audience, to appease a set of audience, and some more scenes to appease one more set of audience, and some more scenes like that. So finally, our movies have become a set of scenes to these 6 or 7 clusters of groups. I can quote many movies examples today. And as a data scientist, when I look at this scene, I understand, okay, director is thinking to appease this. The best example is the movie Bahubali. Of course, it's a very good movie, but there have been scenes to please certain group of audience actually. Right. So that's where classification versus clustering is happening. So by the way, classification, you have clear labels, okay? Default or no default, churn or no churn, buy or no buy, click or not click. That's classification. Clustering doesn't start with groups. Clustering says that, hey, I know my data has groups, but I don't start with it. Okay, I don't have labels also. So if you give me clustering data, the label is absent here. Okay, and that is the broad difference between clustering and classification. And your classification becomes supervised learning, and clustering becomes unsupervised learning actually. Okay, so that's where a simple use case, bank is building clusters, what are the features which they can take, etc. So that I already covered. Now, supervised learning example is a spam email. So by the way, I was talking about Google's 20 years ago when they built spam application. In those days, the report spam was very prominent. Even today, you have a report spam button because they need to get the data to classify. Because if I don't have data, let's say email content and label, if this kind of data is not there, then it will be very hard to build a classifier. So these guys, they go and build a lot of content by whenever you do report spam actually. In a way, if you report proper spam application, you are helping Google build the data set actually. Same thing with your comment moderation also. Today, if you look at Instagram, Twitter, LinkedIn, you can actually report content. It could be comment, it could be post, it could be a message in a private window also. So when you report them, it asks you to classify. And silently, they store all the reported data actually, which will be used to basically train the model. And whenever in future someone is trying to post, and if it has profanity or if it has any extreme language, for example, it auto detects and it tries to stop you from posting itself. Sometimes it disables also. So this is how these platforms start collecting the data. One of the key feature there is report feature where it is used as a data collection steps itself. Now, as a data scientist, we are responsible for this kind of ideas also. When you build applications, it's not just, hey, building the models. Data collection is also one of the important part of our work in real life. So another example is, hey, this is an image, this is cat, this is not cat, etc. So labeling this data itself was a big challenge. So over the years, we've labeled thousands and thousands of images, and we built a data set called ImageNet. And that's where your world of computer vision took off very seriously. So that's what problems AI solves. Your regression and classification comes under supervised learning. Your clustering stops at is best example for unsupervised learning. Then there is one type of algorithm which is a supervised learning approach itself, but you call it as more as instance-based learning. So what is instance-based learning is, hey, you are not getting a global model here. Hey, I'm not getting an equation. I'm not getting a pattern here. I'm not getting a line here. What I do is, hey, I look at the nearest neighbors, and based on the nearest neighbors, I decide, hey, what is this particular person about? We do this a lot in your real life. So in your towns or cities, let's say you have some neighborhoods, places. Okay, this is the place he's coming from. He's known for this, right? We try to form stereotypes sometimes based on that in real life. And let's say if you want to know income of a person, you try to ask him which company, which location, which job role, and based on that, you can actually estimate a person's earning also, right? So all this we do in our head, instance-based learning. You know, 5 people who do that, and based on that 5 nearest neighbors, you can decide this person's attribute also. Same thing applied to data is what your instance-based algorithm is. So K nearest neighbors is the algorithm name. K nearest neighbors basically looks at your nearest neighbors and based on that decides which class it is. So the other type is model-based learning, which is your typical classification. Hey, I'll find a boundary, I'll separate this side points and I'll separate this side points. So instance-based learning is more about, hey, I'll find the nearest neighborhood and based on that, I'll decide it. Okay, so I'll talk about broadly on the entire AI side. We'll talk about different techniques. So we have statistical models, machine learning models, and deep learning models. Of course, now you call them as AI, Gen AI, etc. So what is the broad difference between these kind of algorithms is one is the type of data they work on. Okay. You cannot get a large language model and try to predict something out of it. Maybe it will generate code, you can train it and you can predict, but they don't take direct input and predict. Similarly, your tabular model. So tabular models are different. Large language models are different. Gen AI models are different, right? So these statistical models are age old. Machine learning is recent past. Examples could be decision tree, random forest, etc. These are simpler models which work on small data, can be very easily explained. Whereas there are medium complexity, works on small and medium type of data, explainable to an extent. And good part is these two are public and open source. Now, when it comes to deep learning, they're hugely complex, work only with large data, cannot be explained so easily, very hard black box kind of model. If you ask how the prediction is coming, you may give the intuition, but you cannot tell pinpointedly how it is predicting. And today, as of today, most of them are closed source, proprietary model. You pay and you get predictions. Yeah. And finally, there are constraints on applying because they don't work on any data types. These are statistical models. And you just need simple compute. And statistical models are still very prevalent in production. Though you learn about very complex models, but still people love statistical models because they're explainable. And when you go for enterprise kind of companies, they look for trust, they look for reliability from the models. Okay, they don't look at accuracy. Accuracy takes the last seat. Okay. And machine learning models, also medium level compute, ML are slowly being adopted. The new age companies are employing ML so drastically, actually. And finally, if it's deep learning models, they're being left, right, and center used, but deploying, especially on the enterprises side, is pretty slow. It will take time for them to absorb them. And some of the examples, ordinary least squares method, logistic regression, time series, AR, MA, ARIMA, SARIMA, etc. Optimization, you have simplex. Machine learning are SVM, decision trees, random forests, k-nearest neighbors, XGBoost, PCA, hierarchical clustering. These are more unsupervised. Deep learning are RNNs, transformers, CNNs, graph neural networks. Right, so that's where I stop this lecture. I hope you enjoyed the session. So if you have quick questions for 5 to 10 minutes, I can happily answer.
Okay, sir. Thank you very much for this insightful session. It really helped us understand supervised learning, and also how we have so many options, how about the history of uh, this kind of techniques. Okay, guys, so the room is now open for questions. We will be picking questions from live chat only. So make sure to post your questions on the live chat. And we have about 10 minutes for this Q&A session. So feel free to ask any questions you want. So we already have one question. So that is, which technique do you use most in day-to-day life?
Okay. See, first thing is it depends upon the problem statement. Okay. Tabular. So basically tabular or non-tabular models. In the case of tabular, you come to use case, whether it's regression or classification. Now, let's say even if you choose regression or classification, you have a lot of flexibility because either regression or classification, you have at least 10 problems. Sorry, 10 algorithms actually. So you have to look at constraints there, which is the client or customer okay with any kind of models, which is explainable or not. If they put an explainability condition, then you fall back on only statistical kind of models. If no explainability constraint, then all the advanced models, for example, you can take XGBoost itself and look into it. So as of today, the SOTA is state of the art is XGBoost, right? And different versions of XGBoost. So if explainability is not a constraint, directly go ahead with XGBoost. There is one downside to it, which is if your data is too small, let's say less than 100 data points, etc., then these kind of algorithms might overfit. Complex models will overfit there. Then you have to fall back into simpler models, maybe a small decision tree or small SVM, etc. So that's how you broadly see. Main constraints are explainability. If client is okay with complex models, if it is complex models is okay, go ahead and use SOTA. SOTA is state of the art, right?
Okay. Great. So you have another question. I think you kind of explained it already, but I will just say, how do you decide whether a problem should be treated as classification or regression?
Okay. See, what is that you want to predict? That's what you have to look at it. We call it target label, or we call it as ground truth there. Mainly, is it a number? Is it a class? Okay. Cat or dog, image classification, this person or that person, all can be clearly classes, right? If it is not class, then it is falling into regression itself. If it's a number, a numeric quantity, then it's regression. There are some cases which are borderline form, feel like classification. For example, grades. I have to predict grade 1, 2, 3, 4, 5, let's say. So some people confuse it with class. But is grade 5 better than grade 1? Right? Grade 5 is better than grade 1. So we call this as discrete variables. Discrete variable is also can be regressed actually. There are techniques to do discrete regression also. Okay. Don't do classification there. Classification is only cat and dog problem. So two classes, think of it as your head. Think in your head, hey, is this number? Can I say 1 plus 2 is equal to 3 with this variable? If 1 plus, so cat plus dog is not deer, right? So that means it's a class. But grade 1 plus grade 2 will become grade 3, right? So that's how you understand. So this starts at the variable level itself. You have to decide, is it a numeric variable or is it a categorical? If it's a numeric, you're doing regression.
Okay, great. So another question. How much data is usually enough to train a reliable supervised model?
Oh, okay. See, very domain specific, very situation specific. But I can give you ballpoint. Generally, 100 to 1,000 data points are enough for your least squares methods. Okay. There are cases where even with 50 points also you can do statistical models. Same with logistic regression also. With 20 points also you can build a model. Okay. But the generalization happens. Generalization means model understands the pattern really well when you have larger data. Okay. So as your data set increases, 10,000 points are there, you can try a decision tree. 100,000 points are there, you can start an XGBoost actually. And by the way, this also depends upon the problem complexity also. So the problem complexity is understood only with the domain, right? So there might be a credit default problem which is very neatly balanced and bifurcated. With 50 points itself, model will learn. Even you add 50,000 points, the model will remain the same in the credit default because it is the same pattern repeating again and again. But there could be a case where it could be a regression, it could be some other fault detection problem, where as the data size increases, the complexity is increasing. That means points are spread across. You need a very complex kind of model. So you never know. That's where you have to always, in general, when you are fitting machine learning, we go from simpler to complex models. Okay. If the simpler model is solving it, then good. If complex model, we don't go to complex models. And on data side, as a data scientist, I will say grab all the data as much as you can, until and unless your customer says, "Hey, I don't have anything more," right? Because better data, more complex models, then better results. That is the thesis. If you don't have constraint is there, then work around the constraints. So that is the idea.
Okay, awesome. So another question from chat, that is, how do we balance accuracy and processing latency for real-time tasks like network packet classification?
Okay. Again, you have to assign some cost there, right? If you're looking at latency, right? Let's say look at Uber. Uber can come up with a very complex model for pricing. Okay. But they are losing the customer if you don't give pricing within 1 second. All right. It's the same problem the Google faces also. You take search more time, customer is gone, right? The first 10 results. So in all these applications, latency is more important than accuracy. Okay. So they don't try to profit out to the last 1 rupee. Okay. And they try to, hey, within 2 seconds, sorry, within 1 second, what can I do? So that's why you look at Uber's pricing model. It is surprisingly simple. They don't release it, but it's a very simple model. Okay. But, and one more thing is they engineer a lot for that simplicity. They do a lot of iterations to make calculations very easier, right? So that is the core idea. By the way, if you look at Google, Google gives you 10 pages when you search, right? It doesn't produce all the 100 results at once. The first page results are produced fun. And anyways, you take time to load and read them, right? So no one searches and goes to second page immediately. So that's why they compute second page later. They don't compute second page at all, but they show you. So that's one innovation they do, right? Same thing with Uber also. They approximate. So that's the downside. So in high latency applications, it's always simpler models which take precedence. Yeah.
Okay, sir. So I think we will be taking our last question. That is, can a supervised model continue learning after deployment, or does it need to be retrained with the new data?
Oh, okay, very good question. No, it doesn't retain. See, once the weights are fixed, you deploy. Okay, it's a fixed model. It's an equation which is put in deployment until and unless you change the equation. So that equation changes happens when you retrain. So typically what happens is people keep on retraining chain. Every 3 months retrain, every 6 months they retrain. Sometimes you can automate that retraining, wherein you put a data pipeline. the entire training will happen and model is productionalized. Automating retraining is very risky because no human, no testing, etc. is challenging. So a lot of people retrain after 3 months, 6 months. They have a frequency based on which they retrain. So that's how it works in practice. So that's why we need humans. So that's the reason I said model is not one-time task. So once it is generating ROI, you need a dedicated team. Yeah.
Okay, sir. So I'm not seeing any other questions
Cool.
right
Cool.
now.
Yep. Perfect.
Okay, so I guess we will wrap up our Q&A session for today.
Yeah.
A massive thank you again as our guest today, sir, from AI Planet for taking the time out of their busy schedule to share their expertise with us. And
Yeah.
I hope everyone enjoyed this session. Now, just a quick reminder to all of you who are in the chat to give that hackathon before tomorrow's deadline so that you will be you can check whatever we have covered in our course. Also, check out Mr. Prudhvi sir and his team, AI Planet.
Yeah.
Also, a new initiative that is built publicly. So, I hope you guys will check out that. Again, thank you so
Yeah.
much, sir.
Yeah, one last thing. So I also teach on YouTube. I recently started doing it. So 1 minute. I want to share the link. I hope it's okay. So
Yes, sir.
yeah, so you can find me on YouTube. Yeah. So I've recently started teaching online. I do live classes a lot. I've been doing it for quite some time. By the way, my website is supervisedlearning.com. So in 2017, 2016, I became a data scientist. I noticed that this domain is still free. So I thought I'll grab it and grabbed the domain supervisedlearning.com. That's where I teach
Okay, sir.
through paid courses. But I'm just sharing the YouTube here. If you like the session, please do subscribe. It will be a great benefit to me. And please do spread the word among your network as well.
Yes, sir. Sure. So, guys, be sure to check out Mr. Prudhvi sir's YouTube channel and website. Again, thank you very much, sir, for joining us today. Now, we will wrap up our session. Have a fantastic day, guys, ahead. Keep learning, and we will see you in the next session.
Yeah. So this chat goes to YouTube chat directly, Pushkar?
No, sir, not this one, but we will paste this link in the chat.
Yeah. Thank you so much. Thank you. Yeah. Sure. Thank you.
Thank you, sir.